Hello all, this is M. Sandeep Kumar and I welcome you back to my YouTube channel Concepts of IIT Maths. In today's class we will see how to draw the graphs of inverse trigonometric functions. In our first video we have already introduced to inverse trigonometric functions. We have seen the introduction of inverse trigonometric functions. In the first video we have seen how to define the various inverse trigonometric functions with their domains and also the range. So in today's class we will see how to draw the graph of inverse trigonometric functions. Okay, so for that, first of all let me draw the table with various inputs and also outputs. First let me draw the table of theta and sin theta, and using it I will draw the table of x and sin inverse x. Okay, first of all theta sin theta. Take the values of theta in the restricted domain of sin theta. The restricted domain of sin theta is from minus pi by 2 comma pi by 2. Okay, take various values in this restricted domain. I will take minus pi by 2, minus pi by 4, that means minus 45 degrees, 0, pi by 4, pi by 2. Okay, now, so now sin of minus pi by 2 will be minus 1. Sin of minus pi by 4 is minus 1 by root 2. Minus 1 by root 2, if you rationalize the denominator, you get minus 0.707 approximately. Sin 0 is 0. Sin 45 degrees is 1 by root 2. And sin 90 is 1. Let us use this. And input for sin inverse x, the function, inverse trigonometric function of sin x is sin inverse x. Now input is x and the output is sin inverse x. So let input is x and output is sin inverse x. Just interchanging them here, that's it. For sin theta, input is minus pi by 2, output is minus 1. It is interchanged here. So here, if input is minus 1, then the output is minus pi by 2. That means what? Sin inverse of minus 1 is minus pi by 2. Similarly, if input is minus 0.707 for sin inverse x, then sin inverse of minus 0.707 is how much? Minus pi by 4. So sin inverse of 0 will be 0. Sin inverse of 1 by root 2. 1 by root 2 means 0.707 is what? Pi by 4. And sin inverse of 1 will be pi by 2. So this is the table that we are going to use to draw the graph of sin inverse x. Y is equal to sin inverse x. Okay now, so let me draw x axis and y axis. X and y. On inputs we will take x and in outputs we will take sin inverse x. Remember dear students, input of sin inverse x will be a number and output will be an angle. Okay na? So input, what is the domain of sin inverse x? So it is from minus 1 to plus 1. And what is the range of sin inverse x? It is minus pi by 2 to plus pi by 2. You got it? Some more values, let me mark it on the graph, on the y-axis. 0 degrees. Okay, this is pi by 4. Minus pi by 4. And this is pi by 4. Now let us start drawing the graph of y is equal to sin inverse x. So when input is minus 1, output is minus pi by 2. And this is 0.5. Minus 0.5 and this is minus 0.7. When input is minus 0.7, the output will be minus pi by 4. Okay. When input is 0, output is 0. Sin inverse of 0 will be 0. And this is 0.5, this is 0.7, here 0.7. When input is 0.7, the output is pi by 4. And when input is 1, the output is 1. So the graph of sin inverse x, if you draw properly, it comes like this. Some of them, they will draw arrow mark here and here. That is not correct. That's it. There is no more extension of the graphs. Okay, now keep this in mind. Draw the graph of y is equal to sin inverse x properly I have seen some of them drawing the graph of y is equal to sin inverse x like this. It is not correct. And I have seen some of them drawing the graph of y is equal to sin inverse x like this. That is also not correct. Please observe this. This is the graph of y is equal to sin inverse x. Remember. And next, when input is increasing from -1 to +1, the output is increasing from -π/2 to +π/2. As input increases, the output also increases. Therefore, we say that y is equal to sin inverse x is an increasing function. Keep this in mind. Which functions are increasing functions and which functions are decreasing functions in inverse trigonometric functions. Okay, na? So it will be useful while deriving the formula later in the future and while remembering the formula. Okay, na? So remember, sin inverse x is what function means? It is increasing function. Okay, it is increasing function. As input increases, the output also increases. Okay, na? Similarly, same way, let us draw the graph of all the remaining trigonometric function, inverse trigonometric functions. The next one is cos inverse x. Next one is y is equal to cos inverse x. For that, first of all, let us take theta and cos theta. Theta and cos theta. Okay, now, so if theta, remember the restricted domain of cos theta, which is from 0 to pi. That means I am taking the inputs from 0 to pi. Cos 0, when theta is 0 degrees, cos 0 will be 1. So cos pi by 4. Cos pi by 4 will be 1 by root 2. 1 by root 2 means approximately 0.707. And then cos pi by 2. When input is pi by 2, cos pi by 2 is 0. And then when input is 3 pi by 4. 3 pi by 4 means 135 degrees. Cos 3 pi by 4 is again minus 1 by root 2. Minus 1 by root 2 is approximately minus 0.707. And finally cos pi is minus 1. And if cos theta is equal to x, then theta will be psi cos inverse x, correct or not? As cos theta is equal to x, then theta will be cos inverse x. So theta becomes cos inverse x. So the input for cos inverse x will be x and the output will be cos inverse x. Okay, na? So instead of writing it separately, I am making it within a same table. So for cos inverse x, input will be x and the output will be cos inverse x. Let us draw the graph of cos inverse x. The input changes from -1 to +1 and the output changes from 0 to pi. Okay, na? Input changes from -1 to +1. The output changes from 0 to pi. So exactly in between we have pi by 2, and between 0 and pi by 2 we have pi by 4, and between pi by 2 and pi we have 3 pi by 4. Input is x, output is y is equal to cos inverse x, or cos inverse x is equal to theta. That is the output. Input will be numbers, output will be angles. So first of all, when input is 1, the output will be 0. So when input is 1, the output is 0. Here is the graph, graphical point. Next, when input is 0.707, the output is 45 degrees. 0.7 approximately. When input is 0.707, the output is pi by 4. Next, when input is pi by 2, when input is 0, the output is pi by 2. When input is 0, the output is pi by 2. Next, when input is minus 0.707, this is minus 0.5, this is minus 0.7 approximately. When input is minus 0.707, the output is 3 pi by 4. The output is 3 pi by 4. And when input is minus 1, the output is pi. When input is minus 1, the output will be pi. So joining these graph points, so this is the graph of y is equal to cos inverse x or cos theta is equal to cos inverse x. Again, we don't have any arrow marks here or here. Please observe this. It is not going to extend. The domain will be minus 1 to plus 1. The range will be 0 to pi. Okay na? So once again I am writing that the domain of cos inverse x is minus 1 to plus 1. The range is 0 to pi. It's very important to remember them. Very important to remember domain and range of inverse trigonometric functions. So this is how we draw the graph of y is equal to cos inverse x, or f of x is equal to cos inverse x. You got it? So next thing is you have to say whether this graph, the graph of cos inverse x or cos inverse x itself is increasing function or decreasing function. As input is increasing from minus 1 to plus 1, as input is increasing from minus 1 to plus 1, the output is decreasing from plus pi to 0. It means what? As input increases, output decreases, which means cos inverse x is decreasing function. At the end I will summarize, okay, now how to remember who are increasing functions and who are decreasing functions. It's very easy. At the end I will summarize. Next we will see how to draw the graph of tan inverse x. To draw the graph of tan inverse x, first let me take the graphical points, the inputs and outputs for tan x itself, that means tan theta. Take theta and tan theta first of all. The restricted domain of tan theta is between minus pi by 2 comma pi by 2. So I will take values of theta between minus pi by 2 comma pi by 2. When theta approaches minus pi by 2, because actually theta cannot be equal to minus pi by 2. As theta approaches minus pi by 2, tan theta approaches minus infinity. So please understand, we should not write tan theta equal to minus infinity. When theta approaches minus pi by 2, then tan theta approaches minus infinity. Okay na? Next, minus pi by 4. When input is minus pi by 4, tan of minus pi by 4 is minus 1. Next, 0. When theta is 0 degrees, tan 0 is 0. Pi by 4. When theta is pi by 4, tan pi by 4 is 1. Pi by 2. When theta is pi by 2, when theta approaches, please observe, it's only approaching. Not exactly. Here also approaching. When theta approaches minus pi by 2, tan theta approaches minus infinity. When theta approaches plus pi by 2, tan theta approaches plus infinity. Approaching from which side means from left side. That means a value which is just lesser than pi by 2. Okay, now here a value which is just more than minus pi by 2. Keep this in mind. We will discuss more about this in the chapter of limits in calculus. Okay. So anyhow, come to this. Now to draw the graph of tan inverse x, let tan theta is equal to x, then theta is equal to tan inverse x. So tan theta, if it becomes x, then theta will be tan inverse x. That means if input is x, then the output will be tan inverse x. So this is inputs and these are outputs. So I am going to draw the graph of tan inverse x. Let me draw x axis and y axis. The domain of tan inverse x is minus infinity to plus infinity, and the range of tan inverse x, the range of tan inverse x is from between minus pi by 2 to plus pi by 2. Okay, so let me look at some more points in the output. 0, pi by 4, minus pi by 4, and then here 1, 2 and so on, minus 1, minus 2 and so on. And dotted lines at output pi by 2 and output minus pi by 2. Why means the output cannot be equal to pi by 2 and the output cannot be equal to minus pi by 2. Tan inverse x cannot be equal to pi by 2. Tan inverse x cannot be equal to minus pi by 2. Okay na? So the dotted lines are very important while drawing the graphs. So input is x, output is tan inverse x, which is equal to theta. Okay. So first of all, I will start with this one. When input is 0, the output is 0. When input is 0, the output is 0. When input is 1, the output is pi by 4. When input is 1, the output is pi by 4. You got it? And if possible, you can take an input between 0 and 1. 1 by root 3. You know it. What is 1 by root 3? Root 3 by 3. 1.7 by 3. 1.7 by 3 is 0.56 or something, right? Yes. So you can take one more also if needed, but I am not taking it. If you want, you can take. Okay. So now as input approaches infinity, output approaches pi by 2. Okay, now as input approaches infinity, output tries to reach pi by 2. So keeping this in mind, this is the graph of tan inverse x in the right side. See, when input approaches plus infinity, the output also tries to approach the output called pi by 2. Okay, now similarly, when input is minus 1, the output will be minus pi by 4. You got it? So when input approaches minus infinity, the output also approaches minus pi by 2. So the graph. This is the graph of y is equal to tan inverse x, or theta is equal to tan inverse x. You got it? Please keep this in mind that these two lines should not touch, and here also these two lines should not touch. They will touch when input approaches minus infinity or plus infinity. Okay, now that will never happen, right? Input cannot be equal to infinity or minus infinities. Okay, this is the graph of y is equal to tan inverse x, or theta is equal to tan inverse x. Similarly, we can draw the graph of remaining three trigonometric functions, inverse trigonometric functions. But one question: is tan inverse x an increasing function or decreasing function? You have to check it. As input changes from minus infinity to plus infinity, the output changes from minus pi by 2 to plus pi by 2. That means as input is increasing, the output is also increasing. As input increases, the output also increases. What does it mean? It means that tan inverse x is an increasing function. Let me write like this. Tan inverse x is an increasing function. Okay, now so remember, sin inverse x is increasing function, cos inverse x is decreasing function, then tan inverse x is increasing function. At the end we will summarize it. Okay, now next one is cot inverse x, the graph of cot inverse x. The graph of cot inverse x. First of all, let me take the inputs for theta and cot theta. So theta, cot theta. Okay, now so first of all, the restricted domain of cot theta is between 0 and pi. Okay, when theta approaches 0 from the right side, that means 0 plus 0.00000000 something. Okay, now then cot theta approaches plus infinity. If you have any doubt whether it is approaching plus infinity or minus infinity, so we are approaching 0 from the right side, 0 point something. The angle is 0 point something means angle is in first quadrant only, right? First quadrant, all trigonometric ratios are positive. So cot theta is also positive, so plus infinity. You got it? Remember like this. Okay, anyhow, 0, pi by 4, and then pi by 2, then 3 pi by 4, and then pi. So theta is pi by 4, cot pi by 4 will be 1. Then input is pi by 2, cot pi by 2 is 0. Cot 3 pi by 4 is minus 1. Cot pi will be, again input cannot be pi. Here also when input approaches pi from the left side, that means pi minus something. Okay, now a value which is closer to pi, infinitely closer. Okay, then as input approaches pi, then the output approaches minus infinity. Here also if you have doubt, pi minus something means an angle which is just lesser than pi. That means just lesser than 180 degrees. That angle is in second quadrant only. In second quadrant, cot theta will be negative. So plus infinity or minus infinity, it will be minus infinity. Okay, now anyhow remember like this. And if cot theta is equal to x, then theta is equal to cot inverse x. So if cot theta is equal to x, then theta will be cot inverse x. The input will be x, the output will be cot inverse x. Now if you draw the graph of it, I hope you are familiar with how to draw the graphs from your previous classes. Okay, now so input changes from minus infinity to plus infinity. the output changes from 0 to pi. Okay, fine. So as input x changes from minus infinity to plus infinity, the output changes from 0 to pi. Again, the output cannot be equal to 0, the output cannot be equal to pi, because the output only approaches 0 or pi for cot inverse x. Okay, remember again, x is the input for cot inverse x and cot inverse x is the output. So x is the input, y is equal to, or theta is equal to cot inverse x is the output. So input is x, the output is cot inverse x. Input is x, the output is cot inverse x. Now plot these points on the graph. So here again with some more inputs and some more outputs, 1, 2 and so on, minus 1, minus 2 and so on. So this is pi by 2 and this is pi by 4 and this is 3 pi by 4. If you are interested, try taking more values like pi by 3, pi by 6, 2 pi by 3, 5 pi by 6, etc. Okay, now then your graph will be more precise while you are drawing. Okay, so anyhow, when input is, I'll start from 0. Okay, when input is 0, the output is pi by 2. When input is 0, the output is pi by 2. Yeah, moreover, the output cannot be pi, the output cannot be 0. Please observe this, the dotted lines. The output cannot be pi, the output cannot be 0. Okay, continue. When input is 0, the output is pi by 2. When input is 0, the output is pi by 2. When input is 1, the output is pi by 4. When input is 1, the output is pi by 4. And when input approaches plus infinity, the output approaches 0. When input approaches plus infinity, the output approaches 0. Draw the graph. As input approaches plus infinity, the output is approaching 0. Similarly, when input is minus 1, cot inverse x is 3 pi by 4. When input is x minus 1, the output is 3 pi by 4. Okay, now, so then when input approaches minus infinity, the output also approaches pi. This is the graph of theta is equal to cot inverse x. The graph of theta is equal to cot inverse x. Remember, these two lines should not meet. This graph of cot inverse x should not touch this dotted line. Here also the graph of cot inverse x should not touch this x-axis. Okay, now, and now the next question that arises generally is what? Cot inverse x is increasing function or decreasing function? Very simple. As input changes, as input increases from minus infinity to plus infinity, the output decreases. It's decreasing from plus pi to 0. When input increases, the output decreases, which means cot inverse x is what function? It is a decreasing function. Cot inverse x is a decreasing function. Sin inverse x and tan inverse x are increasing. Cos inverse x and cot inverse x are decreasing. Okay, next two more are the secant inverse x and cosecant inverse x. The next one is secant inverse x. The graph of secant inverse x. First of all, theta secant theta. Okay, remember the restricted domain of secant theta looks alike of its reciprocal cos theta, which is from 0 to pi. Okay, now 0 to pi, the restricted domain. What is the restricted domain? The restricted domain is 0 to pi except pi by 2. Except pi by 2. Okay, now, so theta also will be from 0 to pi except pi by 2. Some inputs. So 0, I will try to take pi by 6 also, pi by 4. Okay, now, and then I cannot take pi by 2. Remember this. I cannot take pi by 2. Then 2 pi by 3 or else, okay, 5 pi by 6 or else 3 pi by 4, 5 pi by 6. Instead of taking pi by 6 and 5 pi by 6, let me take pi by 3 and 2 pi by 6, because I will get rational outputs. Pi by 3, 2 pi by 3, 2 pi by 3 and then 3 pi by 4 and then finally where pi by 2 should not be taken. Okay, now yes dear students, Secant 0 is reciprocal of cos 0, 1. Secant this is what, 60 degrees. Secant 60 degrees is reciprocal of cos 60, 2. Secant 45 is reciprocal of cos 45, root 2. Root 2 is approximately 1.414. Okay na? And we don't have output here. Secant pi by 2 is not defined. Okay na? So next, secant how much? 120 degrees is reciprocal of cos 120. Cos 120 is minus 2. Minus cos 60, minus 2. And cos 135, I mean secant 135 is reciprocal of cos 135. Cos 135 is minus 1 by root 2. Secant 135 is minus root 2. Minus root 2 means approximately minus 1.414. And finally, cos pi is minus 1. So secant pi is also minus 1. Let me show these points. I mean, if secant theta is equal to x, then theta is equal to secant inverse x. Okay now, the input changes from, of course, let me take the x-axis and y-axis. Remember the restricted domain of secant inverse x. The domain of secant inverse x. What is the domain of secant inverse x? The domain of secant inverse x is minus infinity, comma minus 1 union 1 to infinity. Minus infinity, comma minus 1 union 1 to infinity. And the range of secant inverse x is 0 to pi except pi. So I'll take minus 1, minus 2 and so on minus infinity. Then plus 1, plus 2 and so on plus infinity. Okay, so output ranges from 0 to pi except pi by 2. Pi by 2 cannot be taken means draw a dotted line. It becomes easy for us to draw the graph of the inverse trigonometric functions if you know where to draw the dotted lines. Okay now, so next, pi by 4, that means 45 degrees. 3 pi by 4, 3 pi by 4 is 135 degrees. Next, we have also taken pi by 6. Pi by 6 is 60 na, 60 comes here, 30 comes here, 60 comes here. Okay, and this is pi by 6, or let me write 60 degrees itself. And then we have also taken 120 degrees, 120 comes here, lesser than 135, 120, here is 120 degrees. Okay, now let me draw the graph. When input is 1, if secant theta is equal to x, then theta will be secant inverse x. So for input will be x here and the output will be theta equal to secant inverse x. Input is x, output is secant inverse x. Input is x, output is secant inverse x. When input is 1, when x is equal to 1, when input is 1, the output is 0. When input is 1, the output is 0. The graph point is here. Next, when input is 1.414 or 1.4, the output is pi by 4. So this is 1.5, 1.4. This is 1.4, the output is pi by 4. Next, when input is 2, the output is 60 degrees. When input is 2, the output is 60 degrees. And when input approaches, okay, let me try to draw it. And please observe one thing. As input approaches plus infinity, the output approaches pi by 2, but it will not touch. Okay now, they will not meet. Similarly, when input is minus 1, the output is pi. When input is minus 1, the output will be pi. Next, when input is minus 1.4 approximately, minus 1.4 will come here now, the output will be 3 pi by 4. The output will be 3 pi by 4. Okay, when input is minus 2, output is 2 pi by 3. When input is minus 2, the output will be 2 pi by 3. And as input approaches minus infinity, the output also approaches pi by 2. So this is the graph of secant inverse x. Theta is equal to secant inverse x. The graph of theta is equal to secant inverse x. Okay now. So next question is whether it is increasing function or decreasing function. You can easily decide this. As input increases from minus infinity to plus infinity, as input increases, the output is also increasing. Please observe, the output is increasing. The output is increasing. So therefore, secant inverse x is an increasing function. Secant inverse x is an increasing function. So sin inverse x, tan inverse x, secant inverse x are increasing functions. Okay now. Similarly, before continuing this video, you try to draw the cosecant inverse x graph. Okay now, and after that verify whether you are correct or not. You got it? So don't watch everything. First you try drawing cosecant inverse x graph and then cross check whether you are correct or not. Okay? So anyhow, I will draw the graph of cosecant inverse x after this. So first of all, let us take theta and cosec theta. Theta, cosec theta. The restricted domain of cosec theta looks like its reciprocal sin theta minus pi by 2 comma pi by 2. So what is the restricted domain of cosec theta? It is from minus pi by 2 comma pi by 2 except 0. Except 0. Okay, let us take the inputs for theta from minus 90 to plus 90 except 0. So some inputs. Minus pi by 2, next minus pi by 4. For cosec theta, cosec 30 degrees is 2, correct or not? Rational number. So I will take minus 30 and also plus 30. So minus 30 means minus pi by 6, next minus pi by 4. Next 0 should not be taken, please observe this. And then next pi by 6, pi by 4 and finally pi by 2. Finally pi by 2. Okay now, so finally pi by 2. So when input is minus pi by 2, cosecant of minus pi by 2 is minus 1. Cosecant of minus 30 degrees is minus 2. Cosecant of minus 45 degrees is minus root 2, that means minus 1.414. Cosecant of 0 not defined. Cosecant of 30 degrees 2, cosecant of 45 degrees root 2 and cosecant of 90 1. Okay now, so if cosec theta is equal to x, then theta is equal to cosecant inverse x. Okay, x cosecant inverse x. So let us draw the graph of theta is equal to cosecant inverse x by taking inputs. Yes, what is the domain and range of cosecant inverse x? The domain, in place of x, what values can I substitute? It is minus infinity comma minus 1 union 1 comma infinity. And the range of cosecant x, cosecant inverse x, the range of cosecant inverse x is minus pi by 2 comma pi by 2 except 0, except 0. So anyhow, minus infinity, this is minus 1, minus 2, plus 1, plus 2, plus infinity, pi by 2, minus pi by 2, this is minus pi by 4, and we are taking which one? Minus 30 degrees also, na? That comes here, minus 30 degrees. Okay, this is plus pi by 4 and this is plus 30 degrees, and here minus 30, this is minus 30. Okay, so now let us look at these inputs. What is it? When input is x, okay, output is cosec inverse x. Remember, when input is minus 1, the output is minus pi by 2. When input is minus 1, the output is minus pi by 2, and before that, where is the dotted line? The output cannot be 0. That means what? The x-axis itself is the dotted line. The x-axis itself is the dotted line. Please observe. We will draw the graph easily if you know where is the dotted lines here. Okay na? The x-axis itself is the dotted line. So when input is minus 1, the output is minus pi by 2. When input is minus 1, the output is minus pi by 2. Next, when input is minus 1.414, minus 1.414 is between minus 1 and minus 2. What is the output? The output is minus pi by 4. The output is minus pi by 4. Next, when input is minus 2, the output is minus 30 degrees. The output is minus 30 degrees. Now, as input approaches minus infinity, the output approaches 0 degrees. Similarly, if input is plus 1, the output is pi by 2. If input is plus 1, the output is pi by 2. If input is root 2, that means 1.414. Here is the input 1.414 between 1 and 2. Okay, now the output will be 45 degrees. And when input is 2, the output will be 30 degrees. Joining this, as input approaches plus infinity, the output approaches 0. So when here input is x, the output is theta is equal to cosec inverse x. So this is the graph of theta is equal to cosec inverse x. Okay, now next final question is what? Is it an increasing function or a decreasing function? What is it? As input increases, the output is dipping down. The output decreases, correct or not? As input increases, the output decreases. What does it mean, sir? Cosec inverse x is a decreasing function. Cosec inverse x is a decreasing function. So therefore, final conclusion. Who are the increasing functions and who are decreasing functions? Who are increasing functions and who are decreasing functions? This is very, very easy. You will never forget this. You will never forget this. It's very, very easy to remember who are increasing functions and who are decreasing functions. First of all, who are decreasing functions? The functions which starts with the letter C. What are they? Cos inverse x, then cot inverse x, then cosec inverse x. These three are decreasing functions. When input increases, the output decreases. Next, who are increasing functions? Increasing functions. So as input increases, output increases. Who are increasing functions? They remain. What are they? Sin inverse x, tan inverse x, and secant inverse x. These three are increasing functions, whereas the ones starting with the letter C are decreasing functions. Cos inverse x, cot inverse x, and cosec inverse x are decreasing functions, and these three are increasing functions. Why we have to remember who are increasing functions and who are decreasing functions? You will understand when I derive the upcoming formula of inverse trigonometry. Okay, now so in the upcoming videos we will see what is sin of sin inverse x, cos of cos inverse x, tan of tan inverse x, cot of cot inverse x, secant of secant inverse x, cosec of cosec inverse x, etc. Similarly, sin inverse of sin x, cos inverse of cos x, etc. We will see this in the upcoming videos. And moreover, there are many formulae in inverse trigonometry which you feel it's very difficult to by heart. We will make it easy. We will see how to remember them also. Some shortcuts how to remember them, and along with proofs. See, our main intention of this channel, my main intention is to make sure that the students are having 100% clarity when it comes to concepts. That is my main intention. You got it? So once it is attained, then we will see how to solve problems also. So thank you, dear students, to listen the class with lots of patience. I appreciate you for that. In case if you have reached up to the end of the video. So, and if you have understood this concept, like the video, refer it to your friends, and subscribe the channel if you are new to it. So we will see with more inverse trigonometric formulae and derivations in the upcoming videos. So we'll continue in the next class. Thank you.